like to acknowledge Kelly's efforts. Cam and I have sat on the sidelines, and she's done everything to make this look really, really flash. So thank you, and thanks to Glen Eira. I just wanted to make one point about the chat. So if you've got anything that you want us to expand on further, pop it in the chat, and Kelly will message us, and we'll see if we can answer it as we go. If not, we'll save or tally up those questions towards the end. So Cam and I are pretty, well, Cam, but we're both pretty geeky on this subject, and we like to talk passive house and building science. So Kelly's there to keep us on track. So if there's particular things that may jog your memory during the session and you want to talk about it because you've got your own example, we'll do that at the end. So I'm more than happy to hang around and talk to those people about a specific issue. We're not here to give you consultant guidance or advice, but we'll point you in the right direction. Righto, let's get this underway. So, I mean, about 4 years ago, I had no idea about Passive House. By chance, I stumbled on it. I ran into another dad in the school playground, said I was building a bespoke house. I was going to put awesome hydronic heating in, underfloor heating. And from that point onwards, this gentleman said, look, have you heard about Passive House? And from that point onwards, I started scratching the surface, and then, yeah, I'm here today now. I've got a Passive House, soon to be certified, hopefully, Cam. We haven't done it yet. Fingers crossed. And yeah, I'm reflecting, and it's been an amazing journey. It's been busy, and I've kind of lost faith a few times, but we got there in the end. So I suppose what does it really mean, sustainable house? And I suppose I'd start by saying is Passive House is not always 100% sustainable. There's upfront capital costs or costs in materials that potentially aren't sustainable. So it kind of comes back to your own purpose in what you're trying to build or create. Is how are you going to make that difference in terms of sustainability? Are you going for a zero carbon house, or are you going for a low energy operations house? Or you could be going for both. So I suppose I reflect on my decisions early on, and they weren't really about a sustainable material approach, although I really like timber, and we used a lot of timber, and that's quite good. There is a lot of concrete and steel, a little bit of steel in the building. So that is less desirable from a carbon picture. I suppose these images on the slide here are some of the things I've got here in my office today, and I still refer to them. They kind of go in order of complexity, and the Green Home building, that's in Glen Eira Library, so go and get that. That's a free one. The one in the middle you can buy for $20, and I'm not sure about the third one. I think it's also in the library, and they're a great form of self-education that you can use. And it's not just about Passive House. It's like Kelly was saying at the start, is if you've only got a certain amount of money to do improvements in your home, these help you make some pretty prioritized decisions. Additionally, in my journey, I was really fond of listening to some of those podcasts there. They're hyperlinks, so you can click on them if and when Kelly provides the recording. And it's amazing what you can pick up. Like I went from not knowing nothing to feeling like I was comfortable completing the design consultants course, which was pretty intense in terms of physics. So from zero to consultant qualified, I felt like I could talk to Cam.
So I think I just add a couple of thoughts there to that.
Yeah, go ahead.
So just the book there in the middle, from Beyond Zero Emissions, is a really good one. If you're looking at making incremental improvements to your home, you're not doing a deep retrofit or building new. The book on the right there, Positive Energy Homes, is a fantastic non-technical introduction to Passive House. So those of you who may have heard of the term, or perhaps even haven't heard of the term Passive House, but don't necessarily have a technical engineering science type of background, the book on the right is a really fantastic non-technical introduction to what Passive House is. And I think the message that comes through strongly in that book is that Passive House is first and foremost about comfort and health, and notions of sustainability and low energy come as a result of dealing with the comfort and health aspects. And coming back to one of the other things Jonathan mentioned a few moments ago about this compromise we constantly have between the materials we use in buildings and the embodied carbon of those materials and the operational energy, so the ongoing energy required to heat and cool our buildings. Usually the operational energy over the lifetime of building is something in the order of 70 to 90% of the total carbon footprint. So in terms of thinking about that balance, it's really trying to reduce that operational energy, which is going to have the strongest impact over the lifetime of the building on the carbon emissions.
I forgot that point, Cam, and you make me feel a little bit better, because maybe the design life's now 100 years. Then,
And of course, that's the other point, isn't it, Jonathan? We can't have disposable buildings. We've got to design buildings for 50 to 100-year lives, or even longer if we look back at some of those medieval European buildings, some of which are timber, which are still going strong after 500 plus years. There in a way is a very sustainable building.
Yeah, thanks for those points. And the book on the right's also by an Australian author, so it's great to read someone from Melbourne, Monash, I believe, in their building science area. So that's a great book. And I was, surprised to see that it's close to us and it's happening here. So these people are all over these subjects. And I think I wanted to answer the why. Why did I go down this path? And as an engineer and a problem solver and a project manager, I think it comes down to the science. Comfort, yes, 100%. It's about comfort, but to maintain or to, I suppose, guarantee that comfort or performance of a house, you need the science, and that's what did it for me. There was a number of times we weren't going to build it because we felt it was too expensive, and there was several machinations of finance or changing the scope a little bit to see if we could get it over the line. But ultimately, it came down to, we've got this performance-based standard that has shown to have worked for several years. The model, the model that we're going to talk about later is very much close to the performance that it produces, post construction. So that was it. Is if I could guarantee my family was going to be comfortable all year round at 24 degrees, and basically I was signing up to a guarantee, I was sold. So that's it.
We talk a lot about the performance gap, Jonathan, the difference between the as modeled building and the as constructed building. And with the construction code, building to the Australian Construction Code, we tend to find that the as built buildings are often very poor outcomes for the occupants, because they don't detail in the way that we do in Passive House, and then do the quality assurance, things like the air tightness testing. That is a key part of Passive House.
That jogged my mind, and I remember going, when I was looking for properties to buy in Caulfield, or in this area, about 4 years ago. I remember going into one of those new kind of dual occupancy dwellings, and the real estate agent was opening it up for inspection, and all the windows was in the middle of summer, and all the windows were upstairs open, and the aircon was blaring. I was like, wow, it's hot up here, you know. And you just think, why would I spend X amount of $1 million on a house that it's brand new and my kids can't sleep upstairs because it's too hot? And that's one of those frustrating factors, is we've got a building standard or code that says don't worry about it, just build it to this, and you know you'll be right.
And to give that further context, Jonathan, I also live here in Melbourne in a passive house, or near to passive house. And this summer we didn't use the air conditioner for cooling at all, not once. And I think the previous summer we might have used it on 1 or 2 afternoons. So maybe that gives you some context about the difference we're talking about in terms of building performance.
So I might jump over to the next slide. Thanks, Kelly. He's all over it. Well done. The picture up the top is the 1930s dwelling, 2-bedroom, 1 living area that we sadly knocked down. We did live there with 3 kids prior to COVID, and then COVID forced us out. Yeah, it was a quaint little house, and it had a huge gas heater, so it took about 10 minutes to warm up. And the kids loved it. It's a brilliant area, so we chose to go, well, let's put our money into it and make something of it. This is the town planning approved floor plans. And I suppose one point is that I did a previous round of approvals prior to knowing about Passive House. And so this approval was done prior to the Passive House kind of concept being discussed with CAN. And the point I would like to make here is that it's a lot easier if you know you want to do a passive house. You start off designing it like a passive house, because there's some pretty important factors like form factor, the shape of or the area of the perimeter, and the amount of glass you put on, that you can change in that concept design phase prior to approvals, that can get you over the line with the standard or make a massive difference. And I've got an automatic light in my office, sorry, energy saving. That makes a massive difference in getting you across the line for achieving the requirements of Passive House. So, Cam, any points there to kind of emphasise?
Yeah, so Jonathan, I mean, I'm sort of speaking my own book here in a way, but I always say model early, model often. The earlier you can start, if you're building new or doing a deep retrofit, the earlier you can engage a passive house consultant, or that may be your architect or an independent consultant.
Would you do it even if you're not going passive house, or you can't afford passive house?
Well, it depends on what we define as passive house. So we have certified passive houses, which is what Jonathan is doing, which is a process where there is an additional layer of quality assurance. So we go through and use the passive house modelling tools, and we submit all of the documentation associated with the building to an independent certifier, who then operates on behalf of the Passive House Institute in Germany, essentially to sign off on the modelling and the documentation to confirm that this building really does meet the Passive House standard. The lesser one may be someone who says, look, I'd like to get Passive House performance, but I'm not necessarily interested in that additional quality assurance step. And even then, I would argue that it's really important to get that modelling initiated very early in the design process, because that will save you an awful lot of time reworking further down the track, and also a lot of money on construction, because just about any building can be made to be a passive house. But if you happen to have a lot of your glass to the south and you have a very elongated form factor, a word which I'll come back to in a moment, then the costs will go up exorbitantly. So a lot of the cost management here can be affected by what you do in those very early conceptual design stages.
So, some people ask me, Cam, and I'm going to put you on the spot, is should I wrap it? What if I just do all the insulation and the windows, but I don't wrap it?
Yeah.
Like, and I start to go, oh, I can't. It's hard to answer that question. So what? We'll go into wraps a bit later, but I suppose note this response down.
So, and we've got a slide coming up on this. It's sort of passive house as a system of components, and for a building to function well, it needs to hit several targets. It needs to be thermally comfortable, so you have to have the indoor temperature at a nice, comfortable level. You need to ensure you've got a good indoor air quality, and so that those two can sometimes be in competition with one another, because on one hand, if you want to have a very thermally comfortable building, you need to have a very nice and airtight building to prevent all that winter cold air rushing in or summer very hot air rushing in. But then that would deteriorate the indoor air quality. So we need to have these other parts there as well. And also, building science is fundamentally about heat and moisture. And if you can control heat by putting lots of insulation into a building, but then that introduces additional risks of getting condensation in your building. So you need to be very careful when you're doing one of those two things, heat and moisture management, to make sure that you're not leading to perverse outcomes.
So you didn't really answer the question. You can't put science to that issue, and I think that's the challenge I find when people say, "Oh, I'm not sure about the wrap." Like, I'll do windows and insulation, but the wrap that just seems wrong. Anyway,
it's risky, Jonathan, I think, is the answer I would give.
Yeah.
The world is probabilistic. You can't say for sure a building's going to succeed or fail. But
it's like taking a few variables. You're taking a few variables out of the equation, saying, I can still solve it. Come on, it's not that hard. I'm only a few tens of thousands off. I'm fine. Okay, so what we built is just the standard Melbourne family home. It's 4 bedrooms. It's got 2 living areas. It's a kitchen, 2 bathrooms. In this case, it's got a fancy pool out the back, but that nearly didn't get ahead. I suppose what I've noticed is it's amazingly quiet. We live on not a very loud street, but there's a bus route on the street, and so I remember in the old house hearing the bus, the diesel engine, and the brakes. And in the new house, it's very quiet. There was also this guy down the road who had this massive V8, and he'd start it up every morning, and I can't hear it anymore unless he's moved, which I don't think he has. I can't hear that either, so it's really good. So the quietness is quite good. Having 2 living spaces is also good. That's not a passive house thing. And I suppose the thermal gradient, and it's a bit technical. The thermal gradient is about the temperature from your toes to your head. And I love talking about this to Melbourne people, because originally I'm from New South Wales and I've moved around the country and lived in most of capital cities. Is that Melbourne has this uncanny temperature where it'll be like 5 or 6 or maybe 10 degrees on the floor, and your feet will be freezing because they're old floorboards and there's no insulation. And then you've got your gas, or maybe you've got your heat pump heater or your hydronic heaters, and all the heat is kind of on the top third of the building, and that's toasty. So you've got maybe your t-shirt on or your jumper, but you've got this 10 through to, let's call it 35 degrees up the top. It's really unbearable, and I haven't got any of that. I don't wear socks, so I can walk around, and you can see there the concrete slab is a fairly decent temperature. It's probably 22, 23, and my temperature gauge downstairs, I don't have any upstairs yet, but it's very similar. It's running at about 23. I think I've switched the aircon on once during summer. That was prior to us moving in, just to cool us down when we're painting or doing some final fixtures. Cam, what's your favourite thing about a passive house while we're hitting that?
Yeah, I'd say I agree with the quietness aspect, Jonathan. It's incredible how quiet it is when you have this level of insulation, triple glazing in both of our cases, and air tightness in combination.
I'll go back a set. Is the dust? I mean, I thought passive house would solve my dust issue. It hasn't solved it completely. I still have to clean, which I'm a bit disappointed about, although my kids don't. There's still dust on the floor. I thought the passive house would like mop up all the dust and just take it outside. It doesn't do that. It does a little bit of it because I've pulled out and already cleared the filters out of my HRV, but I suppose there's less dust, and I feel like the air quality is a little bit, well, I just don't feel the negative effects of bad air quality. It just seems normal. So I think that's another thing. I think this slide's Cameron's, I believe.
So this is what we were alluding to a little bit before. So passive house is really a number of components. And critically, I'd argue you need to really do all 5 of these in order to guarantee that you're not going to have perverse outcomes. None of us wants to live in a house that's got lots of insulation, but also has lots of mold and condensation. That would be a terrible outcome. So passive house needs lots of insulation, of course. Yeah. I think we just saw Kelly's calendar. So lots of insulation. So in a Melbourne climate, a passive house, usually, to give you a rule of thumb, probably has about twice the level of insulation as a code compliant house. It requires passive house windows. The windows are always the weakest part of the thermal envelope in a building. And that applies even if you have very high performance double or triple glazing. And as I mentioned before, both Jonathan and I have triple glazing. That's not necessarily required to achieve the passive house standard in Melbourne. Much depends on the building's orientation, how much glazing there is, and any number of other factors. But certainly high performance double glazing is an absolute minimum. And that includes the frames as well. So many frames that you would buy, window frames that you would get, conventional frames in Melbourne, are aluminium. And aluminium is a fantastic conductor. So no matter how good your glass is, whether it be double or triple glazed, if you've got an aluminium window frame, the heat will just transmit around the corners, around the frame, and you also risk getting condensation. So you must use a thermally broken aluminium frame, UPVC, which is a form of plastic, or timber. Thirdly is adequate ventilation. That really goes on with air tightness to the right here. So Jonathan mentioned this before in talking about a membrane. A membrane is really a fancy word for a fancy sort of plastic. So in a passive house, we wrap our buildings. We make them very tight. Essentially, you could think of them as being wrapped in a plastic bag, but it's not quite that sort of plastic. And that air tightness is a really key part of creating both the low energy use by preventing air from getting in and leaving the building, and also in avoiding moisture issues in the building. Now, once you build very airtight, obviously you risk having a situation of having poor indoor air quality. And the solution to that in a passive house is something called a HRV, heat recovery ventilation, or also known as MVHR, mechanical ventilation with heat recovery. They're the same thing. It's basically a box, and we'll show you some photos of one in a moment, that sits in the middle of the house somewhere, that brings in fresh air from outside, distributes that, heats it up through a heat exchanger, distributes that to all of the living spaces in the house, and extracts from the wet spaces, the bathrooms and the kitchen. And that system runs 24/7. You don't have to do anything. It's just fit and forget. Every 6 months, you'll go and change the filters. The thing will beep at you. You change out the filters and you just leave it. And if you go away on holidays, you can turn it into a thing called away mode if you like, but probably you can just leave it because the power consumption is so low. And then the final component really comes back to the insulation. This is about continuous insulation, avoiding thermal bridges, in particular, which are things like, say, for example, if you have steel in your construction, Steel is a really excellent conductor in much the same way that aluminium around window frames are. And so you really have to avoid the heat transfer across that steel, both for energy reasons, but again, also for condensation and mold reasons. If you have steel in your wall and then put plasterboard in front of that wall, there is a very high risk that you will get condensation and mold forming a strip along that plasterboard, because that steel is like a thermal runway.
I suppose it's a bit of comfort as well. So if you've got, steel windows or aluminium windows, that comfort, you can start to feel that inside as well.
Yeah, and we call that radiant temperature. So the way we feel a temperature in a room is the absolute temperature, 20 or 25 degrees, the movement of air, so that cool breeze that we might get coming through in the middle of winter, and also the radiant surface temperature, so the temperature of the surface of the walls, the window frames, the floor, and so on. So in Passive House, we have a whole lot of standards that require those surfaces to be very close to the ambient air temperature to create that perception of comfort.
Can I go back there, Kelly, for a sec? Like when people, I sound like one of my kids, when people ask me about Passive House, I just say, look, it's a super insulated esky with a ventilation control system on it. Eskies are, we massively thick walls that are insulated. In this case, the plastic bag inside is the plastic for the esky, for the inside of the esky. There is absolutely no thermal. You'll see in eskies, there's no thermal bridges. There's no bits of steel or metal going from the inside to the outside. And I suppose, just looking at it, is that we've really controlled the climate or the environment of the inside and eliminated any of those issues of vapor or moisture in the envelope. And I suppose that's pretty clever on Passive House, is that stuff is really complicated and guesswork. By eliminating it, you've just got this controlled environment. And I suppose I want to shoot one question back at you, Cam, and say, when we talk about thermal bridges, how much of an effect does it have in terms of the model? So, thinking back to mine, there was a few cases where we had some steel and we had some issues where the timber was directly inside to directly outside. What effects can poorly designed, even passive houses or houses have when you've got these thermal bridges? What effects does it have in terms of performance?
So performance can be defined in a few different ways, Jonathan, but the obvious way you probably mean it is energy. So how much
or score in terms of meeting the requirements of Passive House.
Yeah, so in Passive House, the thermal bridges must meet two criteria. So the energy demand, so we must minimize the amount of energy transferring out of the building, and the thermal bridges become very significant when you increase the level of insulation. So if we go back to the scenario I was talking about before, where we double the level of insulation compared to code, then the thermal bridges are becoming disproportionately more important. Or to think about it another way, if you just build to code, from an energy point of view, you've got so many problems, quite frankly, that the thermal bridges are just one of those problems. But when you deal with the insulation, then the thermal bridge becomes more important. But in either case, the condensation risk remains the same. And so the last thing any of us want in our buildings is to have condensation and mold. And so that applies universally, no matter what we're doing with our buildings. And so there's some very stringent criteria within Passive House that requires that thermal bridge detailing be dealt with very carefully.
So it's bad. It's bad either way. That's what I read.
Well, none of us want mold.
Okay, cool. Sorry, Kelly. Go ahead. Next one.
So maybe I just jump in here, Jonathan. So there's a couple of slides here for me probably. So as I alluded to early, model early, model often. The greater the use you can make of thermal modeling early in the design process, the greater insight you have as to how your building is going to perform and to drive down the costs of construction. And this comes back to this question that constantly comes up: how much is a passive house going to cost? And the answer, of course, is it depends. And it depends on how early in the design process you consider the passive house
And
elements.
how would you do it? Like, I mean, for the purpose of this presentation, when does a client see a passive house and how does it work? A passive house consultant, sorry.
So ideally around the same time you engage an architect or a building designer. So that many architects and building designers are now certified passive house designers. So they can do the modeling, the passive house modeling for you at the same time as they do the design. That's not always the case. And so often I'll be engaged early on by the client, working with the architect during the concept design phase. And we're still at the point of looking at the massing of the building, how it's oriented, how big the windows are going to be. And I'll be presented with a number of scenarios where the client says, we want this floor plan, we want windows here and windows there. Let's run an initial model, see where we're at. And the passive house designer will come back with some suggestions about some changes that could be made. And as is always as part of the design process, that must be balanced against all of the other functional requirements that you have. But the earlier you can do that, the greater the control, the greater control you'll have over the costs.
And what about the your cost in terms of time at that stage? So that sounds like the best approach. If you can, sorry, I need to reset my clock. In terms of doing a model at that concept phase, how many hours do you put into that? How long do you generally take to build a model, something like that on the screen? And what's the random rough order of magnitude cost for that service?
So
not trying to promote your business or anything, but probably gone up since I've paid you.
So an initial concept model can be mocked up fairly quickly. So the building, like you see on the screen here, might take, say, a day to build up, and then to populate into the model another half a day or so. And you can do that in the order of about $1,500, $2,000, depending on the complexity of the build. And then often you'll need to iterate from there. But because the basic shell of the building is already extant, and you're just probably playing around with windows, maybe putting a wing here or there, then it becomes a much lower cost going forward from there.
Sorry, I'm stealing your presentation, but I think that's really important to kind of note, is that the biggest effect you can have on the design is in that early modelling, and that initial model to say you could kind of get passive house, or there's zero chance with your beloved design, because everyone gets attached to their design, and then you do the model and you're like, oh.
And that's exactly right, Jonathan. You can save tens of thousands of dollars on the construction cost at that very early design stage. And that applies to all of the other specializations involved in building as well, structural engineering, for example. But the thing that the model really gives us power in is asking those what if questions. So as to give you an example, people often talk about, should I get double glazing? Should I get triple glazing for my building? And it's easy enough to go and get a quote from a supplier as to how much each of those options may cost for your building. But what's the benefit? And usually we're left to speculate and say, oh, in Melbourne, you don't need triple glazing, or you don't need double glazing, or whatever. But the benefit of the model is you can test what the impact is going to be on your space heating and cooling loads. And this is just an example output of that. This is a building where we start with, we've got the heating demand here. So a high number means that you need more energy to keep your building warm in the winter. So we're trying to minimize this number. So we're starting off with a building around 58. Doesn't really matter what the units are. And then we find if we make the building really airtight, so we go from a standard new Australian building, which is relatively air leaky, to make it passive house level airtight, we can almost halve the heating demands of that building. And then if we incorporate a mechanical ventilation system, we reduce it further. We can increase the floor insulation. We can increase the roof insulation. We can put triple glazing in. We can see how we can make progress towards the passive house standard. And we can run all of those different combinations of scenarios to get there and work out what is the most cost-effective one to to do.
So there was a few questions on cost in the chat, and I suppose I might just touch on is that you can build an expensive non-passive house. I mean, there's a lot in the fabric of a passive house in terms of these key core requirements, and you can have a terrible standard of finishes and still get a cheaper passive house, or you can decide to go big windows and open areas and spend more money on timber beams, and you can have a more expensive passive house. So it's really whatever you want. I mean, I suppose the question out there is can I build a cheap passive house and still have a lovely house? And I suppose that's up to what your standard or comfort of living is in terms of, I would say, aesthetics and function. But when it comes down to the core elements of cost for passive house, this is where you can actually save money to kind of identify the cheapest ways you can afford those core elements and get your greatest wins for your minimal amount of dollars.
Maybe we should take this cost question now, Jonathan, while we're on the topic.
Yeah, right, let's do it.
Critical. So I try to answer this in three ways. So the first and simplest way is it'll cost you an extra 10 to 25%. That's a rough order.
In
capital construction costs. It can be at the lower end if you've got a nice tight building, so a small surface area to volume ratio, as Jonathan has, and not a huge amount of glazing. And on the other hand, if you're in Trentham, Ballarat, up in the Dandenong, somewhere really cold, and you have a building with lots of sprawling wings, then it will get a lot more expensive. So it might be closer to the 25% number. The second way of looking at it is a dollars per square metre rate basis. And that's a really problematic measure because so much depends on what you do for your internal finishing. But to give you an idea, most architectural level passive houses now, and Jonathan's is an example of this, are coming in at least $5,000 a square metre. So that sounds pretty expensive, but I would argue that most architectural standard homes are coming in at $5,000 a square metre too. Setting aside the passive house.
You could build a refrigerated, container and still get a passive house, provided you don't do any thermal bridges. Like there are options out there to be really cheap with your passive house, but like you wouldn't live in a refrigerated container.
That's right.
So.
And the third way I just do the costing on this is you need some extra insulation, obviously. So let's call it $5,000 to $10,000 of extra insulation and the labour associated with installing that. You've got the membranes for the air tightness, so call that an extra $10,000. Then you've got the mechanical ventilation system, which we alluded to. Supply and install of that is in the order of $20,000. And then the single largest component is the windows. So the windows package for a fairly standard sized sort of new build home in Melbourne is probably in the order of maybe 30 to 50K, depending on what exactly you're getting. For passive house, they're likely to be quite close to twice that. So call that in an extra 50,000. What we need to bear in mind with those additional costs, we've got savings as well, because you don't need that hydronic heating system. You don't need that central ducted heating and cooling setup or evaporative cooler or whatever you're thinking of using. And of course, your operating costs are about almost nothing, 10% of what they would otherwise be. So that hopefully gives some flavour as to where the costs are likely to land.
And I think this is still a fringe market. So you just have a look at how many people in Melbourne or in Australia have done it, and there's not many. And just like buying electric cars, as things start to change, government incentives start to change, policies start to change, it'll get cheaper because people have to build like this. And we're not there yet, and that's why we're not seeing, the Metricons and the Simmons houses going, our option 4 is $1 million passive house and you can get it in 12 months. And, here's the 4 passive houses we have. That's not there. There are a few companies that do, I suppose, bespoke building cassettes or houses that have a standardized panel that is certified passive. But again, it's not priced as a kit home. It's priced as a bespoke architectural package, and it's not cheap because low volume. So there's no solution. There's a hole in the market, but it's basically volume.
Yeah.
So you can't just go out and buy a cheap passive house, unfortunately, unless you want a refrigerated container with a HRV on it.
But I keep going back to, Jonathan, you're getting a different product. If you want a code minimum home, then that will come out cheaper than a passive house.
Oh,
Like,
yeah.
Apples and oranges.
Totally.
Yeah.
But I'm saying is, I mean, when I was looking at passive houses, I was on a quest to get that kit home at a reduced price. Like, that's what I thought I could find, and I didn't, right?
Yeah.
But it's like that holy grail is, why can't we be in Europe and get a passive house for roughly, maybe 5% over the code minimum price? And that's what I'm disappointed about, but that's what it is at the moment.
Yeah. So just to carry on, just one final graph just about the modelling. So one of the other questions that constantly comes up is people who are getting solar power, so solar PV or photovoltaics. My answer to that question, how big a system should I get, is always, how big a roof do you have? So as big as you can fit on your roof, and how much can you afford? Thinking that going forward, we're all going to have electric vehicles. We're probably going to use electricity for our heating and cooling and all our internal loads. So our future electricity consumption, if anything, will increase. And so one of the aspects of passive house with the modelling is that we can actually look at what the total home consumption is relative to the PV generation, with the key emphasis from a sustainability point of view on what happens in midwinter. Because it's in midwinter that's the critical case, because that's when our solar is generating least and when our heating demands are highest. And so where passive house really comes into its own is helping to minimise those heating demands.
I'm looking at Eco Kit Home. Someone's messaged on that quest for a cheaper passive house already.
Shall I talk about mechanical ventilation, or do you want to cover that?
You're the expert, Cam. I reckon you do it all weekend, so I'm going to give it to you.
All right, so this is the mechanical ventilation unit. This is a centralised mechanical ventilation unit. And what that means is that I'm drawing in fresh air from outside. So in the middle of winter, that air might be at 5 degrees. And I'm drawing back from my wet spaces, my bathrooms, my kitchen, my laundry, moist, stale air that might be, say, 20 degrees. And then I run them through the heat exchanger, which looks like a honeycomb in the middle of this box that you can see here on screen. And those airflows pass one another in different channels. They don't mix, they just pass one another. And when they pass one another, the heat energy from the outgoing warm air, the 20-degree air, passes into the incoming fresh air at 5 degrees. And it raises the temperature of that incoming air to 20 degrees. So now I have fresh air at 20 degrees that I then feed into my bedrooms and my living spaces, and I get rid of that, what is now cold air, that is also stale and carrying all that moisture. And so what this does is really provides constant, controlled, regulated fresh air into my home. So I know exactly how much fresh air I'm getting. So in a passive house, you don't ever need to open a window because it feels stuffy inside. You only open a window because you want to. You want to hear the birds. It's a nice, lovely day out there, whatever it may be. You don't have to because it feels stuffy. And more importantly, perhaps, is that it's providing that fresh air into each and every room. Whereas in a conventional home, you're having to open windows in each and every room, and you just don't know what the airflow that you're getting into those rooms is. The other thing that the mechanical ventilation is doing is it's got filters that you can see in the middle photo here that clean that incoming air. So if you suffer from allergies like I do, from hay fever, in the spring, Inside, it feels perfectly fresh and you don't get any of that pollen because it's all been caught. And then, of course, it also manages moisture much more effectively. So if you think of your bathrooms when you have a shower in a conventional home, you turn on the extraction fan, that sucks out all the steam in the air. But then after 10 minutes, it switches off. The tiles are still wet. And then over the subsequent hours, the water on the tiles evaporates. And where does that moisture go? Well, it might float back into your master bedroom, down the hall, you don't know. And water kills buildings. And the advantage of these mechanical ventilation systems is it's constantly extracting that moisture from the wet spaces. So it keeps your building drier. And so just to give you an idea of why mechanical ventilation is so beneficial, on the left here, we have a conventional home. So this is a 1940s brick veneer, pretty much like Jonathan's home was before, very leaky. In the middle of winter, and this is the carbon dioxide concentrations in a bedroom. And you can see that the levels are peaking above 2000 parts per million. And the standard for good indoor air quality is about 1000. So just about every night, the master bedroom in that home is the air quality is poor, despite the fact that the building is very leaky. The building on the right is a passive house with mechanical ventilation, and you can see that the air quality is much, much better and consistently so. And of course, the temperature inside will be much higher than the old school home as well. So mechanical ventilation is critical to indoor air quality.
Windows. Cameron mentioned that the largest component or the additional component compared to the code minimum was windows, and that's because they're very hard to achieve decent performance without, I suppose, thermally broken and what are they called? The spacers and argon gas, and these type of windows or the volume of these type of windows just isn't there in Australia. They are there, you can find them, and there are, you know, a few different manufacturers that you can procure from Australia, but a lot of the passive house houses or buildings that have been built have imported them from Europe. I'm sure you could probably do from China, but they're potentially quality control could be a bit of a risk. There's a few different functions with these windows that you might not have seen unless you've been to Europe. And the sliding door here on the left is it's not a tilt and turn, it's a lift and slide. So essentially, to preserve the seals, you lift 250 kilogram door off of the seal and it pivots up on a set of rollers, and then it rolls along. So my 8-year-old can open basically a 300 kilogram door of triple glazed units. And what I like to say to people is that the performance of the window is only equivalent, correct me if I'm wrong, Cam, to about a 90 millimeter standard Australian wall thickness of a bat. So your 90 mil thick walls with, I don't know, like 2.6 or something in the walls. That's as basically as good as you can get. So you can understand that if your whole house is covered in windows at that low R value, you're really going to struggle. So you want to maximize light and you want to have open, airy spaces, but when you're doing your concept design, you want to think hard about $1,000 a square meter for this type of stuff. So don't just cover everything in windows. Think wisely about your project. So we've talked about that. The skylights are in the same kind of ballpark, is that you really struggle to find opening skylights that have good U values, but also have been certified passive in terms of air tightness. A lot of them are quite leaky and have thermal bridges around the frame, so they don't necessarily help you in your model. So again, these windows were procured, these roof windows, the skylights were procured from overseas. They're about $5,000 for 3. They're quad glazed, and they're the best bit of glass on the house because they're always basically facing the sun when it's up, and you need to reduce that heat or solar gain in your house as much as possible. We also put pretty cheap blinds on them, so I'm already starting to think I've mistimed this slide. Already we've used them quite a bit just to cut the heat down, and we've also got some blackout blinds on our triple glazed windows that also cut the solar gain from inside. Now, we talked about something on the weekend, Cam, about what's the difference between treating the solar gain internally and externally. Do you want to kind of cover that? Because I know you had a good point on the weekend about that.
Yeah, so this comes down to summer overheating. So what makes our buildings get too hot in the summer? And the first and foremost contributor to overheating is radiant solar gains through our glass. So if you've got a glass window facing north or west that's exposed to the direct sun from lunchtime onwards, then you'll rapidly get overheating. You need external blinds or a deciduous tree, or as Jonathan has here on the right, a pergola that has got shutters that can be open and closed depending on what you need. So you've got to protect your windows from the outside. By the time the heat's got inside, having a blind inside is far less effective.
I'm trying to answer a question at the same time of thinking about the next slide. I suppose we can talk about the plastic because it's a question that was raised just there, is that it comes down to the materials you use. It's a real personal thing, I think, and it comes down to your motivation. Like, you can go to the nth degree about low VOCs, you know, the logistics, carbon for your timber, plastic, and plastic is obviously not fantastic. It doesn't break down, takes a long time to break down, but it's one of the methods we use to control the climate inside, and it's kind of a necessary evil in most of the passive houses. Some passive houses use timber in terms of there's different products that you can actually get an air seal. Part of the envelope concrete is providing that air barrier, but at the moment plastic is probably the best solution, dare I say it, that allows us to control the environment inside the house.
And Jonathan, just to add to that, if you're going to use a timber as an air barrier, which you can do, so a product like plywood or something called OSB, both of those have lots of glues in them. So we haven't really moved away from petrochemicals by doing that. Unfortunately,
the
it's a
hempcrete,
necessary evil.
Sorry to cut you off. What about the hempcrete and the render? I haven't done much research in the non-plastic air barrier, but
so
I'm sure.
A lot of people are obviously very keen on trying to use more natural materials, which is obviously great. We all support that, and we'd love to have a compostable building that we can just bowl over at the end of life. But a lot of those materials have some really serious compromises that are very difficult to deal with. And Jonathan's example there of hempcrete with render is one of those. It's a very challenging material to work with.
Yeah, so I mean, great question, and it's very hard to live in an all eco-friendly house that's sustainable. Passive houses about making compromise, and I think it comes down to your personal ideals about what you feel strongly about. So hopefully that's kind of scratched the surface of that question. So we've moved on to the next slide. I suppose these are just some examples of, oh, this is your slide. Sorry, Cameron.
I don't think there's much to say on this one, Jonathan.
Yeah,
We're all
I mean,
familiar with glass wool bats.
yeah, I suppose there's two points here. Is that generally the houses have the bats internally to the joists or your frames. So you can see, I'm not sure if you can see my mouse, but the one with the skylights on the right, the glass wool is sitting in between the joists in the ceiling plane. And I suppose those blue beams that painted blue, the joists or ceiling rafters, sometimes you might call it, are naturally thermal bridges. So what Passive House does is we put another layer on top of that, generally perpendicular to the rafters. So you just create another layer, and we often call it the service cavity layer of insulation. Yeah, so that's just a little point for one of those questions. We could probably move to the next slide, Kelly. Passive House is all about going all electric because you put solar panels on the roof and you get free electricity most of the time when it's sunny, and you use it for all your appliances. And given that your electricity demand for space heating and cooling is pretty much very low, you use it for your electrical appliances. I suppose the one here on the right is that you can now, if you don't realise, you can get heat pumps for your hot water system, and they're a very efficient way of pumping heat from outside and transferring it to the water. And they're how much more efficient are they, Cam? I know you were sprouting these numbers compared to
you would talk about 400 to 500% efficiency. So which doesn't feel real.
This is one of those things, yeah, that you can do tomorrow. You can call up and change your gas over to one of these things. There's about 3 or 4 really good ones, or maybe 2 good ones that you can do. And they'll cost you with your rebates probably $4,500-5,000 with the labour install. And if you couple it with solar panels, or if you've got solar panels already, you can time it to heat up during the day, and essentially you're getting free hot water when it's sunny. So that's a groundbreaking kind of thing to have free hot water, because it's one of those, I think you said 30% of your electrical demand.
So energy demand.
Energy demand.
So around 50% of the energy consumed in our homes is heating and cooling our homes. And most of that is heating in Melbourne, and around 30% is our hot water. And both of those can be dealt with using heat pumps. And the concept of a heat pump is really, really important to understand. And it's something, irrespective of whether you have a passive house or just an old school home, you can make really massive improvements in your energy consumption by going for a heat pump. Because what a heat pump is doing, just as the name suggests, is it's harvesting heat energy in one place and moving it to another. And all of your other heating systems are generating heat. They're generating it by burning something like gas, or they're generating it by running electricity through a cable, which then gets hot. Whereas a heat pump, like Jonathan's hot water unit here, is taking heat from the air outside, even in the middle of winter, and it's bringing it in and it's storing it in that tank. And it's really like a battery. So if you have solar PV on your roof and you set this to run in the middle of the day, as Jonathan suggested, then it can turn on at, say, 11 o'clock in the morning, harvest that electricity off your roof, put it into the hot water tank, then that tank might be warm by, say, 1 o'clock in the afternoon, and then that tank will stay warm, sufficient for you to use the water in the evening and have showers the next morning before the process repeats. It's really like a battery, and it comes an awful lot cheaper than a real battery. Jonathan, you're on mute.
Yeah, so another comment there, great comment, is that you don't end up paying a gas connection fee. And it was kind of liberating disconnecting our gas and talking to the people on the phone going, yeah, I want my gas disconnected. They just couldn't understand why I was disconnecting the gas on the call center, wherever they were in Australia. So it's quite funny. But what I'm trying to say is that what becomes quite important in a passive house is, because you've got really no electrical cost if you've got PV, the service connection or the monthly connection fee becomes really important. Some are quite low and have high fees for kilowatts. The others are some of the other way around, whereas a high service connection fee monthly and then low kilowatts. So it's important to shop around because those fees become important. During our build, we decided to be one of those fringe dwellers and get an EV. It's a bit of a revelation. They're great cars to drive, and it's just a car, but it's really something. Not having to pay the petrol is just so good. So what we've got is a 12 kilowatt solar array on our roof, which can charge our car in about 8 hours. We've got a 3-phase charger, so it does about 11 kilowatts an hour. So that's kind of that's the upper end of domestic charges at the moment. And so you can get 500 Ks off 8 hours, and that's massive. So you don't actually need to charge it maybe once a week. I mean, if you're just commuting, it's you can use it as a battery, and so that's what we've planned to do. I've put provisions to allow to run the car battery back into the house to power a few essential loads. So this picture down the bottom, there's a reverse plug next to the wall box, and so we can plug the car in to this power point, and then on our switchboard we can switch it over to running our fridge, our lights, some power points, and any other essential circuits that we deemed. That obviously the HRV would be one of those as well in a passive house. So look, it's probably not the best bit of technology, but it's manually we can essentially run those essential circuits either in a blackout, which doesn't happen very rarely, or sorry, it happens very rarely, but we're not paying for power for those essential items overnight. So that was one of the cool things we did. Okay, airtight testing. Ooh.
So one of the final things we do in a passive house as part of the certification process is we blow air into the house and we suck air out. And we put a fan on the door that you can see here, so the red thing here. And we do that to measure the level of air infiltration into the building. And passive house is rather famous for having very stringent air tightness requirements. So essentially a passive house needs to be something in the order of 20 to 30 times tighter than a conventional code-built new home in Australia. So 20 to 30 times tighter. And compared, say, to Jonathan's previous home here, the 1940s semi,
still good.
50 to 60 times tighter. So extremely tight compared to a conventional home. And as part of the certification process, we need to prove that with the blower door test. So Jonathan, did you want me to cover a bit of this one?
I think you talk more quickly than I do, Cam. So I think this might be a good one for you.
That might be a bad thing. So we've talked about passive house, which obviously makes a great deal of sense if you're looking to build new or to do a deep retrofit. But are there things which you can do without going that far? And there's a great deal you can do. We've really got this great advantage in Australia that the quality of our building stock is so poor that there is so much low-hanging fruit there. So the first thing I would suggest, if you're looking at those really cheap and easy things, is deal with your air sealing. So go to your hardware store, get some caulk around your skirting boards, have a look under your basin where all your plumbing risers are. Make sure you seal up there. Weather strip around your doors and windows. So you can get this rubber material with a sticky backing paper, and you can just put this rubber stripping around your doors and around all of those rattling windows and try to make the building more airtight. That can make a really significant difference. The other thing is obviously lots more insulation. So it's really critically important that insulation be continuous. So if you look up in your roof, the chances are you've had perhaps an electrician who's come in and lifted bats and thrown them all over the place. Or you have bats that don't quite match up to one another. They need to be hard up against one another. They should be nice and fluffy, not compressed. So it's a really easy DIY job to get up there and fluff up the bats, push them all up next to each other. Go and buy a second layer of bats and put that layer staggered on top just to cover up all of those gaps. With your walls, if you're going to paint, particularly this is a good time if you're going to paint because you need to drill holes. And you can do this on brick veneer as well, is you can blow in insulation into wall cavities without having to pull off the plasterboard or pull off your external cladding. And there are companies out there that will do that for you. That can make a really big difference because walls are a large part of your building surface area. What I haven't put here is get new windows, so double or triple glazing, UPVC, timber, or thermally broken aluminium. But of course, that's relatively expensive. And then finally, as we mentioned before, heat pumps. So use the heat pumps for your hot water, for your heating and cooling, and consider the heat pump hot water units for your hot water. And the combination of those two is in the order of 3/4 of your energy. So if you're taking that 3/4 of your energy demand and reducing that by a factor of 4, that's making a massive impact on the total energy consumption of your home.
Question, quick one. I know we're trying to move along, but would you ever attempt to do greater air sealing with a building wrap? You know, like if people are out there going, I've done all this, but I want to, you know, maybe I want to retrofit my house passive. Can it be done? Can you go in and air seal it?
So unfortunately, the only way to incorporate a membrane, which I think is what you're talking about there, Jonathan, is really to pull off the plasterboard. So it's a deep retrofit level of difficulty. What I would suggest to those out there maybe that think they've done all of those things that we've got on that previous page, and I'd sort of challenge and say probably most of us haven't, is you can commission a blower door test. So that red thing on the door that I showed before, there are contractors around that will do this test. Cost is something in the order to $700 to $900. They can come around, do the test. You might not be interested in the result, how tight your building is, but when they pull air out of the building, you'll go around with the back of your hand and you very quickly feel air rushing in through all of those leaks. So if you've had a good go at the leaks and you think you've got them all, consider a blower door test because that will very quickly point you in the direction of the places that aren't as tight as you thought they were.
That's a great point. I never thought about that.
And then just finally, we've just listed here some really useful resources that you could consider that can provide further information.
Yeah, I had some points here, but I think in the interest of question time, Kelly, I mean, we had some.
I think.
Yeah, we had some final remarks, but I think it might be better for getting people opening it up.
That sounds great, Jonathan. Thanks a lot to both of you for your presentations. We'll go straight to, and we have dealt with some questions as we've gone, but we'll go to some of those. So how long did it take for plans and permits to be approved, given Glen Eira's support for energy efficiency and sustainable homes?
Great question. Great question.
You can speak to
Look, I don't think, I mean, if I was advising anyone who wants to expedite their approval process, you'd select a freestanding home on a block greater than 300 square meters, because that's what I had. And it was an attached dwelling. So I had protection works, I had to go through a planning permit, and then I had VCAT as well. So it took like 2 years to get my house from my head to a building permit. So it's not about the passive house. Like, even if I said to Glen Eira, I'm doing a passive house, they probably would have said, what's that, at the time. But it didn't really change the approvals. Now, I previously had a sidebar conversation with Kelly saying Glen Eira should be prioritising passive house, and, you know, over to you, Kelly, in terms of the front of the line to approvals.
Yeah, so for our ESD, or our environmentally sustainable development requirements, like many other metro councils, they just kick in when it's a multi-unit development or commercial development, so 2 or more dwellings. So for single homes, single dwellings, it's basically the construction code that applies, and hence the need to raise the standards of the building code, and we advocate to try to have that happen. But yes, certainly there aren't requirements from council, because we don't have that ability in the planning scheme. That would mean it would take longer or additional assessments to meet energy efficiency requirements. So
yeah, I suppose what I was saying is that the levers council does have is that they own the people who assess the plans for approvals. So could they not prioritise those? I mean, you've got to meet minimum requirements under the Victorian legislation for the Planning Act, but like, instead of 60 days as a minimum, could you not say, look, we'll put you to the front of the list because you're doing a 10-star or a passive house? Or
yeah, potentially some other councils have brought in a bit of a fast track for best practice across all parameters, because I guess, you know, as a council, then maybe that's going to, you know, knock it out of the park in terms of sustainability. But then there's all the other aspects about bulk and neighbourhood character and all the things. So that need to be sort of best practice across all the elements. So it just has a bit of extra complexity to it. But yes, potentially. And the key thing is to try to get that planning scheme amendment approved, and that's in the hands of the planning minister, so that we can raise the bar. We've covered the cost questions. In terms of a list of suppliers and brands, we've got some on the slide there. And Jonathan, there's a specific question about whether you could provide a list of suppliers and brands around more exotic components. And you mentioned some things you import. If you're happy to, you know, you've been very busy, but at some point you can send that to me. And
we can do that. So, I mean, the windows that we've used, a Logic House, they're a supplier in Canberra who import from Poland. I mean, if you've got the budget, you could go to Parheimer. They're a local Melbourne mob, but are about 4 times the price, but fantastic products. I mean, there's some other ones that I don't know of that have popped up. Cam, maybe I'll have to give you the details, but there are the Passive House Association website also has, I'm not sure if they have supplies, do they, Cam? I haven't been on it for a while. They have, okay.
Just to extend your list there now, we've started naming names, Jonathan. For timber windows, another Melbourne-based supplier to consider is BINQ, BINQ. And then you have a wide number of UPVC or plastic window providers. I won't name those because there's tens of them, but they're all generally very good products as well.
So perhaps after this, and we'll be respectful of people's time. If they need to go at 8:30, for sure do. We'll stay as long as there are questions to be answered. But I guess outside of this, we'll collate a bit of a list that we feel we could share, and that'll be relayed back to people who registered for this session, because we could probably talk a lot about particular products and brands, I think. But yeah, a few clues there. That one's more of a comment. So don't know if this will have much of an impact, but Jonathan, did you have any problems when getting the bank valuation to price the home correctly?
Yeah, we had a few questions like this on the weekend about what's a passive house worth. They did not care at all that it was a passive house. However, some banks are now, I don't know, I think it's LVR, like have you heard about this, Cam? I can't really, I think there's 2 banks that are now lending or changing the LVR to people who are building 10-star or passive house, but they actually name passive house. So we could put that, I could just do some research and put that in the info email that we pull out. But yeah, generally banks don't care, even if it's, your capital costs are more and then your operational costs are basically less. That's not something they'll look at unless they're one of those 2 banks.
Yep. And is it generally easy to find a designer? You touched on that a bit earlier, but probably speak to what's happening in the sector there.
There's lots of people doing the passive house designer consultant course, and there's lots of architects who have done the course, and there's lots of people that aren't passive house trained but can work in a team. And I suppose my advice, and it's picking up on a point that Cam raised on the weekend, is these people they're just people, right? That you've got to work in a team with them for 3 or 4 years if you're doing a bespoke house, and you need to have good relationships. So it's about, I would say, finding those people who are passive house trained or at least know about it. But it's more, my sense of project is it's more about dealing with those people that you can, have that relationship and not blow up for 2 or 3 years. And at the end of the job go, we're still mates, and thanks. So it's about trying to find those people, but also about trying to find the people that you can work with. But yeah, there's lots out there. The Passive House Association website has a register of all the consultants. But if you're going to an architect, I think it's, you need to kind of raise that. If you were hell-bent on a passive house, is finding a consultant like Cam or, a myriad of other people who do it, maybe not a myriad, and go to them and say, look, can you team up with my architect? I want to do a passive house, so I want to try and get close to a passive house standard.
That's great. And in terms of the energy performance, so does the house actually have a NatHERS rating, which is the and what is that, is the question?
I don't care, but sorry, I'm being a bit rude. No, I think when we did it, I was trying to tell the energy assessor I was doing a passive house, and he said, "What's that?" But I submitted all the windows with all the U values, and I submitted the the building envelope and the R values, and it came back at like 8.5 or 9 stars, something like that. And I mean, for me, after doing all that passive house research, it's kind of like, well, I'm not doing this for the NatHERS, I'm doing it for passive house, so I know it's going to be good. It just so happens that the NatHERS was high. It's a different comparison, I suppose. Cam, you probably
yeah, just to chip in, this is a really difficult thing because they're 2 different beasts altogether, and to try and compare them is a really fraught exercise because they have different sets of assumptions within them. NatHERS is primarily a regulatory tool. In order to build, you must achieve a certain star rating. Passive house we see is much more of a design tool. although it has obviously a certification standard component to it. They really can't be compared. So yes, if you're building in Victoria or indeed in Australia, you must achieve the minimum NatHERS standard. If you're building to passive house, you can be very confident you will achieve NatHERS, but honestly, I wouldn't be too fussed about what the star rating is.
Thank you. Couple of questions for people making improvements, not necessarily passive house. So what would be the best material to insulate brick veneer walls, and then separate to that, and double brick walls?
Yeah, it depends on several factors. It is that you know, there's a number of places you can insulate. You can insulate on the inside, you can insulate in between, and on the outside. And I suppose we're trying to improve the envelope, and when you start to add those insulation layers, you want to know what the vapor or the moisture is doing when you do those improvements. And the other thing is aesthetics or buildability. And I suppose that's, I'd consider myself a bit more on the buildability side. Is okay, scientifically we want to put it on the inside, but how do we put R3 on the inside of a brick wall that's the facade inside? I mean, what do? You just lose 120 millimeters on every surface of your room. You're making the box smaller. How does that work? So yeah, there's a lot of what ifs there, but I suppose the most logical one, Cam?
Yeah, so the two strategies I would suggest both involve blowing. So drilling little holes either from your plasterboard or through the grout or the on the outside, mortar, sorry, not grout, between your bricks, and you inject either what is essentially chopped up bits of glass wool, so your usual bats that you see in your hardware store. You can look up, or if you Google for a product like Nauf Superfill, SUPAFIL, as an example, and there's contractors around that will install that. And I think we mentioned EnviroFlex as one of those. And the other one is foam, so expanding foam. Again, you need a special contractor, and they inject into your wall an expanded foam, like those little cans you buy in the hardware store of that stuff that just expands into the wall cavity. So those are the two minimal intervention solutions.
And what are those can you get from that blowing stuff? I suppose it just depends on, same as glass wool.
Yeah, well, if it's a 90mm stud, which it normally would be for a brick veneer, then you can get about R2.5 in a 90mm. And if it's a double brick, you've often got about 50mm between the bricks, and that's about R1.1, 1.2.
And I suppose if you wanted to go the whole hog and you said, look, I want to put foam and a false wall, what could you do if you're going to lose, let's say, 100mm of inside of foam? You get R4. Yeah,
it depends what foam material you use. There are lots of options there.
So there's, that's a full retrofit, and you lose space inside as well. So there's plenty of options to do, and there's plenty of different cost points to do.
And is it worth insulating just one wall, the north facing wall, and not the others?
Yeah, I saw that one. So I imagine, but I'm only speculating, the rationale for the north wall was the worries about summer overheating, which, to be fair, if the wall is uninsulated, yes, that would contribute. But I would come back to my point about much of the overheating in summer comes through the glass. So make sure it's not your glass that's actually the primary contributor. As for whether you would just do the north wall, because you're paying for a contractor to come to site, I think you'd find it much more cheaper just to do the whole house while they're there. And in the winter, the heat will move out through all four walls in proportionate to the area of those walls. So you want to do all of them.
To pick up on some remarks you made earlier about solar panels, Cam, is it worth installing panels if the person only has east and west facing roofs? I reckon we know your answer to this.
Yeah, yes. Simply, in fact, it can be even better than putting them north, because you're generating earlier in the morning from the east, and you're generating later in the afternoon from the west. So you're essentially flattening the generation profile to use a technical term. So yes, the only reason why you wouldn't put solar on your roof is because it's heavily shaded. Its shading is what kills solar.
And there's someone here who plans to do a significant renovation in 2 or 3 years. If they change their gas water heater to a heat pump now, is it easy to disconnect, move and reconnect in the new renovation later?
Yeah, totally.
Yep. It's just an appliance. Hey, just get the tradies back in.
You say, yeah, look, it's maybe an extra $1,000 in labour, but you start making those savings now. So,
yep, that sounds good. A good question, I think, about the extent of sustainable house design awareness and knowledge amongst builders and amongst the trades. I guess, does the builder need to have that existing specialist passive house knowledge? How have you gone?
Look, I think it's better to do it, but you're paying probably a premium, and they're very hard to come by at the moment because everyone who wants a passive house is engaging the guys who have done the training and who have done several houses. So I think you'll wait longer to get a passive house builder, but you probably get a better product in terms of their experience and quality. But in saying that, there's people that can supervise it or is there people who can supervise it? There are people, there's certain quality checks that you could do to minimize your risk with a builder who hasn't done the passive house tradesman course.
I just add, Jonathan, I think the key thing here is engagement from the builder. If you're fighting resistance from the very outset to passive house, then you need a different builder. What we tend to find is that the quality builders who tend to be very interested in innovative but difficult challenges.
Craftsmen, the people who are
craftsmen builders or craftspeople builders, then they will tend to be far more engaged and willing to go on the journey with you. But there is a certified passive house tradespeople qualification, and on the Passive House Association website, you can search for tradespeople who might cover your area.
Sounds good. And someone just wanting to confirm their understanding. So the idea is you seal the house and then control the air that comes in and out. I think they've nailed it.
Yeah,
you've got it.
Yeah.
That wasn't hard, was it?
Yeah.
There was a competition on this to simplify it, wasn't it?
Yes. So yes, someone has understood the lesson. And if people are leaving as they need to leave, but I know both of you are happy to continue to take questions, and there are more here. A question about whether your passive house is off the grid. We just be clear about that.
No, we're connected to the grid, and we export solar. To set up an off grid, you need a battery, or just accept that you're not prepared to have power.
And I guess it's worth thinking about why would you really want to do that in an urban context anyway?
I did think about it. It sounded pretty cool for a bit, and then I thought, why? Why do I need it? When am I ever going to stop getting power from the power authority, or in my case, at night, or when I don't have PV? And it's very rare, and it's very fringe, and the frequency might be, I don't know. I've lived in Melbourne for 4 years and I haven't had a blackout, so maybe a few hours each year potentially. I don't know.
It comes down to people's motivations, doesn't it?
But if you were living up at Mount Hotham and the grid was susceptible for blackouts, would you put your passive house on off grid? Yeah, you probably would. But it just costs more to put a battery in.
Yeah, I'll just add that if you look at the cost benefit of the things that you can do in your home, installing a battery and or going off grid, assuming you live in metropolitan Melbourne, is probably the last thing you ought to be considering. There's plenty more things to deal with first.
I wanted a pool instead, yeah.
A pool. Priorities, yeah. Someone here's going to bulldoze and build a dual lock. Do you think the additional cost to build a passive house, presumably, will be realised in a higher sale price?
I think it's a good question, because I think in my earlier days I wanted to do that and to build passive house. Well, there's still more time to build and flip passive houses, but I think the saving is in rental, in terms of you keeping it, and you could get the I suppose an increased rental rent from better comfort, but you could offer to say, look, I'll pay for your power and all your connections. So you include all your service connections and you realise the cost savings there, but you increase the rent in terms of you're packaging all of it together, and that's where the saving is. I think,
and perhaps it's fair to say that at this point, around levels of awareness of buyers in the market, etc., you don't build a passive house thinking it's about getting a return.
You'd have to market it to one of the nuts like Cam and I.
Still quite niche.
And to be fair, we do have a couple of developers now in Melbourne that are doing
passive house,
medium scale development to passive house standard, because they do see it as a marketing niche for them. So it's all about product positioning, I suppose. But to be fair, the jury is still very much out on whether there's a margin in this.
And a question for me, does Glen Eira Council provide rebates for changing gas hot water to heat pump hot water? There are a raft of rebates available from the Victorian government. There's eligibility criteria that apply around household income and value of your home. But for switching over to electric heat pump hot water systems, there are state government rebates, along with rebates or subsidies at point of sale for heating and cooling, all sorts of things actually under the Victorian Energy Upgrade. So we've got those things on our website, and I'll send some follow-up links as well. Could Cameron please go over the ideal cost-efficient passive house shape? I think he used the words like elongated, small surface or something, and describe what that looks like, so sort of bringing the principles to life. Ask you.
So the rule here is surface area to volume. You want to minimize that ratio. And so if you think of back to school geometry, the shape with the minimum surface area to volume ratio is a sphere. So if you can, build your house as a sphere. If you can't do that, the next best thing is to build a 2-story box that's nice and tight. Now, if you think of your classic Germanic house, what does that look like? It's a 2-story rectangle with small windows and a pitched roof. Think of your Swiss chalet, if you like. That works thermally very well because you've minimized that surface area, because it's a surface area that has all the heat transfer across it. Now, what we tend to find, if I can be a little bit careful with my reference to architecture, is that these days we love this idea of building pavilions. So you've got your master bedroom wing out this way, then you've got your kitchen living here and maybe the kids' bedroom over there. And it's a very sprawling shaped building. And so the surface area is very large relative to the volume. And so in order to make that building hit passive house, you would need to make the walls thicker. You would need to go for triple glazing rather than double, say, as opposed to for that tighter 2-story rectangular box where the building fabric doesn't need to be anywhere near as extensive. And so that comes back to that cost question.
And limit your windows.
And limit your windows, consider which orientation. Obviously, north-facing windows are best, but if you happen to have the view to the south, well, that changes things. And there's all those, context matters.
Terrific. And a point probably of clarification or expansion around NATAs, and you can explain that's the national standard. But what's the main difference between passive house versus the star rated NATAs? Like they're both standards, but if we can capture that.
I'm not answering it.
Simply, might be a Cameron question.
Yeah, so I think Jonathan, you said yours was low 8 stars on NatHERS. So,
Yeah.
so as I think we've mentioned, so NatHERS is the regulatory standard. So to build a home or essentially renovate a house in Australia, it must achieve 6 stars, coming on 7 stars, which is translates to an estimate of the amount of heating demand and cooling demand required by that building. Now, one of the reasons why it's really impossible to compare Passive House with NatHERS is that Passive House requires that the building be between 20 and 25 degrees year round. And then it calculates what the heating demand will be in the middle of winter to bring it up to 20, and similarly the cooling demand down to 25 in the summer. Whereas NatHERS applies different temperatures for different rooms in the house. It allows rooms, now I might have this number wrong, so forgive me if I've got this wrong, if you're an expert on this. I think it allows bedrooms to get down to 18 or possibly 16 degrees overnight, and to 18 or 20 or something like that during the day. So as soon as you allow, think of it in your home, changing your thermostat. If you turn down your thermostat by 1 degree, that makes a massive difference to the energy consumption in your building. And so with NatHERS or Passive House, if you're trying to achieve different indoor temperatures, then you're inevitably going to get different energy demand estimates. So it's really hard to compare. The only other thing I would say is the average new Passive House in Melbourne achieves in the order of 7.2 to 7.6 stars, something in that order. So it's not 10 stars, but we in the Passive House community would argue to our death that a certified passive house performs much better than a 10-star NatHERS rated house.
Thank you. And can mold build up in the pipes that are taking the moisture out of the bathroom to the unit, to the mechanical ventilation heat recovery unit?
I'll maybe take that one. So the answer is no. So there's a couple of things going on there. The pipes are either plastic or metal. So obviously mold requires a food source to grow. They're also anti-static, plus the fact that you constantly have airflow through them. Even if you've just had a shower and there's a very high moisture content going up into that duct, and possibly some of it will temporarily, condense, because the airflow is continuous, it will very rapidly be picked up again and taken out of the building. So I'm very confident that any moisture in those ducts will lead to mold growth.
Thank you. We're jumping around, but we're getting on the home straight. What would be a good material for upstairs outside blinds? So thinking about external, I don't know if you have that, Jonathan, on your north.
Yeah, we have
side.
external.
Yep.
I mean anything that blocks the heat. I mean the old traditional blinds in Europe, they have the shutters outside. I think they're canvas blinds. So I mean, some of the older houses, you'd see the European immigrants who had those outdoor canvas blinds. They work fine, I think.
And a request of a supplier, if you have some in particular.
Look, ours came with the windows. They were bespoke to the window supplier, so the system fits all together, and it sits out like a very small roller door outside, like a roller door. So you just press a button inside and it shuts. So it's pretty extravagant. It's saying I need to go to bed.
Almost bedtime with your lighting. It's terrific. I think. Oh, sorry, Cameron.
I'm just going to suggest one brand that regularly comes up, and this is not an endorsement, just to say that's one brand I constantly hear mentioned, is a brand called Helio Screen, Helio Screen. But as Jonathan said, there are plentiful solutions. Much comes down to your aesthetic and the functional requirements you have.
I mean, they're fairly cheap. Like I feel is they're not, it's not complex science here. It's a little electric motor with a Wi-Fi if you've got it, and some rails. Like it's not hard. But I suppose the complex thing is if you've got open out windows, and that becomes a bit tricky. If you've got open in, that's something I didn't mention for those other things, is all our windows are open in, and that allows you to have mechanical blind on the outside.
There's someone here organising final designs for a house on the southern Mornington Peninsula that's determined to be a wildfire zone. Is any of the insulation you recommended flammable?
Maybe I'll go with that.
Anything we recommended? We haven't recommended anything, have we?
Oh, just on the slides, there was glass, wool, and different, very standard insulation products. So I guess the question is, they've probably got a Bell's rating, they've got a meet. Would those materials be suitable in that bushfire context?
So all Australian insulation, insulation sold in Australia has to meet the Australian standard for flame propagation, I think it is. And so they won't be able to hold a flame, but they do have different flammability characteristics. One of the best I can suggest for like extreme for flame zone is to look at a product called rock wool, which is spun basalt, so that lava rock. It looks a bit like the glass wool you buy in your hardware store, but unlike the glass wool obviously is glass, this stuff is rock. And it's used in all sorts of industrial applications where you're trying to contain a flame. But that's for flame zone, Bell flame zone type of situation.
I mean, this type of advice is best to receive from a fire engineer. Yeah, if you're going to go into that kind of stuff, it's not something you can just throw up and be happy with.
And often the bigger issue in flame zone or in Bell regions is just the openings. You need to minimise the ember ingress rather than worry about what the insulation material itself is.
Great. I think we're on to really the last couple of questions. So anyone, if they think that I've missed something in the chat or between the chat and the Q&A, they're in both places, you can put it in the Q&A right now and we'll get it answered. A slightly different take on, I guess, the builders discussion from before. Do the builders need to have special training to work to the level required? Or what's there in terms of accreditation?
If they can wrap a Christmas present, I think, that basically you're taping a big box.
We've all seen some pretty badly wrapped Christmas presents, so sort of about attention to detail, isn't it?
There you go. That's the answer.
Yeah.
It's a basic understanding though, isn't it, Jonathan? I mean, the issue we have with these plastic membranes is that even if the builder is very diligent in installing that membrane and getting the taping right, and then the electrician or the plumber comes in and gets out their knife and starts ripping holes in the membrane to run their cables through, that's a disaster. And so it's really about understanding that all trades on site have a thorough understanding of what that membrane is and why it's there, and detail accordingly. And that comes down to the site foreman.
Or have one person overlooking everyone, and generally that's the site foreman or a builder that knows exactly what's going on. And I mean, I'm not sure if Jason, my builder, joined. He was going to join tonight, but we kind of worked as a team, and we both kind of had an idea of what was going on. And there was a few cases where we had a bit of a worry about certain thermal bridges, and we work with Cam to solve them. So it's not you don't solve all of them at the start, or you just start to build it and realize that you've kind of forgotten something, or one of the trades have done something differently, and therefore you have unwittingly introduced the big thermal bridge, and you need to work out how to get rid of it.
Thank you. And one final little bit out of the box question, we'll see how you go with it. Someone was asking whether the future of sustainable houses might be about homes made from recycled plastic, and whether anyone's assessed the environmental impact of that.
I'm sure this is a chemical engineer type of question, isn't it? Like, look, it'll be great to be able to use a product that's waste and produce passive houses, or even just sustainable housing. What's a sustainable house? A house that has a full life cycle. You can build with it and then recycle it and repurpose it. But I don't know. I think that's a red herring.
Remains to be seen.
I'll just admit that rather than building houses out of plastic, I wish we could build them out of straw. Straw is probably the material with the best sustainable credentials I can think of.
Yeah, natural materials, and then, you know, true end of life reuse or reconstitution. Okay, I think that has gotten us to the end of a very, very massive session, and thank you so much for all of your questions. Big thanks to Jonathan and Cameron, not only for tonight, but yeah, 2 face-to-face events on the weekend and a video and all sorts of things that we've been doing for Sustainable House Day. I'll follow up with some resources, links to the recording, and a feedback survey, and do stay engaged with future events. In May, we'll have another webinar that focuses specifically on winter energy efficiency, getting your house prepped. And as I mentioned, yeah, do make the most of Sustainable House Day right through until the 19th of April. A huge amount of great things that Renew, the independent energy experts, have got on offer. So thank you very much, and good night from all of us.
Thanks, Kelly.